Welcome back to my channel JBR Online Classes. Please subscribe my channel and press the bell icon.
Hi everyone, in a previous video I explained all the definitions and formulas of probability. You need those knowledge for solving the problems. So please go and watch that video. In this video we are going to solve the problem from Emil Aggarwal book chapter 22. If you face any kind of problems, please tell me in the comment box. So let's start. So for any probability problem, we will follow 3 steps. First step is find the experiment from the question. Second step is find the total number of possible outcomes for that experiment. Third step is find the event for which you need to calculate the probability, and this you can find from the last line of the question. So let's start. So this is the first problem, and this problem is saying that a box contains 600 screws. 1/10 are rusted. One screw is taken out at random from this box. Now what is the first step? The first step is find the experiment. Okay. Now here for this problem, what is the experiment? It is one screw is taken out at random from the box. That's the experiment. Okay. Now the second step is you need to find out the total number of possible outcomes. So here it is nothing but the total number of screws, which is equal to 600, because whenever you are picking out one screw from the box, that means what? Any screw among the 600 screw can be picked up. Okay, that's why this number is 600. Okay. Now the third step is identify the event. So for that you just look into the last line of the problem. Okay. So what is the last line? Find the probability that it is a good screw. So the event E is it is a good screw. Okay. Now one more information we have in the problem, which is given, it is 1/10 are rusted. That means what is the number of rusted screws? It is 600 by 10, which is 60. So what is the number of good screws? It is 550. That means 600 minus 60. Okay. Now we all know the formulas of probability, which is P equal to this. So what is the number of favorable outcomes to this event E? Now first tell me what is the property E has. The property is it is a good screw. So this number of favorable outcomes to E has to be equal to number of good screws, which is 540. So the final answer is 540 by 600. So this is problem number 2. It says that in a lottery there are 5 tickets and 995 blank tickets. A person buys a lottery ticket. So what is the first step? The first step is find out the experiment. And what is the experiment here? A person buys a lottery ticket. That's the experiment. Now what is the total number of outcomes here? It is actually equal to the total number of tickets, which is 995 plus 5, because when the person buys a lottery ticket, that ticket can be a prize ticket. Okay. So 5 prize tickets are there, and that ticket also can be a blank ticket, and 995 blank tickets are there. So the total number of outcome is 1000. Okay. Now for the event you just need to read the last line. So find the probability of his winning a prize. That's the last line. Okay. So the event is winning a prize. Now so we know the formula of probability, that P equal to this. Now tell me what is the number of favorable outcomes to this event E. Okay. So what is the property first? So the property of this event E is winning a prize. Now a person wins a prize only he buys a prized lottery ticket, isn't it? So that's why the number of favorable outcomes to this event E is nothing but number of prize tickets, which is 5 in this problem. So the final answer is 5 by 1000. It is 1 by 200. Now this is question number 3, which says that 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at random from this lot. Now what is the experiment here? The experiment is one pen is taken out at random from this lot. That's the experiment. Now what is the total number of possible outcome? It is nothing but the total number of pen, which is 132 plus 12, which is equal to 144. And why is so? Because when you are taking out one pen from the lot, that means that pen can be a defective pen, also it can be a good pen. So total 12 defective pens are there and 132 good pens are there. So that's why this total number of possible outcome is 144. Now for the event, you need to look at the last line. So what is the last line here? Determine the probability that the pen taken out is a good one. Okay, so the property of this event is the pen taken out is a good one. That's the event E. Okay, now we know the formula of PE. So the number of favorable outcomes to this event E is nothing but number of good pens, because the property of the event E says that the pen taken out must be a good one. That's why it is the number of good pens. Okay, and the number of good pens is 132. So the final answer is 132 by 144. It is 11 by 12. Now this is question number 4, which says that two players, Sania and Sonali, play a tennis match. It is known that the probability of Sania winning the match is 0.69. So what is the probability of Sonali winning? Now this question is little different than the previous questions. Here you notice that a probability of an event is given. So whenever some probability of some event is given in a problem and you are asked to find out the probability of some other event, generally we use the complementary event formulas in this kind of problem. Here you see that the probability of Sania winning the match is given and you need to find out the probability of Sonia winning the match. So here we are going to use the complementary event formulas, okay, which is PE bar equal to 1 minus PE, okay. Now here in this problem, the experiment is the tennis match. Two players are playing a tennis match, okay. So we let the event E equal to Sania wins the match. And we know that the given probability P of E equal to 0.69. It is given in the problem. Okay. Now E bar is what? It is the complement event of the event E. Okay. Complementary event of E. Okay. So which is nothing but Sania loses the match. Okay. So complementary event is nothing but just the opposite of the event. Okay. That means Sania loses the match. Now, this match is being played by two players, Sania and Sonali. If Sania loses the match, then Sonali wins the match. Okay, and if you just read the last line of the question, so they are asking that what is the probability of Sonali winning? And Sonali winning the match is just the complementary event of Sania winning the match, isn't it? So P of E bar equal to 1 minus PE. That's the formula of the complementary events. Okay, so we know the value of PE, so it is 0.69. So the final answer is 0.31. Therefore, the probability of Sonali winning is 0.31. So this is question number 5, which says that a bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. Okay, now what is the experiment for this problem? It is a ball is drawn at random from the bag. That's the experiment. Now what is the total number of possible outcomes for this experiment? It is actually the total number of balls in the bag, which is 3 plus 5, which is 8. Because when you are picking a ball from the bag, it can be any ball among the 3 red ball, or it can be any ball among the 5 black balls, isn't it? That's why the number of possible outcomes is total number of balls, which is 8. Now what is the event? For that you just need to read the last line of the question, which is what is the probability that the ball drawn is red? This is the first part. So here the event E is the sentence in the inverted commas, which is the ball drawn is red. Okay. Now we all know the formula of PE. So what is the number of favorable outcomes to E? It is just the number of red balls, because the property of the event E is the ball drawn has to be a red one. Okay, isn't it? So the number of red ball is 3. It is given in the question, and the total number of possible outcome is just the total number of balls. So the answer is 3 by 8. Now for the part 2 of this problem, they are asking that what is the probability that the ball drawn is not red. Now just think about it, that if the ball is not red, then it has to be a black ball, because in the bag only red and black balls are there, isn't it? So the event for this part of the problem is the ball drawn is not red, which is just equal to the event the ball drawn is black, isn't it? So now we just need to find out the probability of the event that the ball drawn is black. So what is the number of favorable outcomes to this event? It is nothing but the number of black balls in the bag, which is 5. So the answer is 5 by 8. So this is problem number 6, which says that a letter is chosen from the word triangle. Now what is the experiment in this problem? It is a letter is chosen from the word triangle. That's the experiment. Okay. Now what is the number of possible outcomes here? It is the total number of letters in the word triangle, which is 8. Because when you are choosing a letter from the word triangle, the letter can be any letter among the 8 letters in the word triangle, isn't it? Now they are asking this question, that what is the probability that the letter is a vowel? So the event E is the sentence in the inverted commas, which is the letter chosen is a vowel. That's the event. Now what is the number of favorable outcomes to this event E? It is the number of vowels in the word triangle, because the property of the event says that the chosen letter should be a vowel. So that is why the number of favorable outcomes to this event E is the number of vowels in the word triangle, which is 3. So the answer is 3 by 8. Now this is problem number 7, which says that a letter of English alphabet is chosen at random. So here the experiment is what? The letter of English alphabet is chosen at random. That's the experiment. Okay. Now the number of total outcomes is just the number of alphabet in the English language, which is 26, because the chosen alphabet could be any alphabet in the English language. Okay. Now they are asking that what is the probability that the letter is a consonant. So the event E is the sentence in the inverted commas, which is the letter chosen is a consonant. Okay. So what is the number of the favorable outcomes to this event E? It is the number of consonant in English language, which is 21, because 5 vowels are there. So the final answer is 21 by 26. Now this is problem number 8, which says that a box contains 7 blue, 8 white and 5 black marbles. If a marble is drawn at random from the box, what is the probability that it will be black? So that's the first part of this problem. So here the experiment is a marble is drawn at random from the box, and the total number of possible outcomes for this experiment is total number of marbles, which is 7 plus 8 plus 5, which is equal to 20, because when you are picking one marble, it can be any marble among 7 blue marble, or any marble among 8 white marble, or it can be any marble among 5 black marbles, isn't it? So now for the first part, the event E is the sentence in the inverted commas, which is getting a black marble. So the number of favorable outcomes for this event E is nothing but the number of black marbles, isn't it? Because the property of the event E is getting a black marble. Okay. And the number is 5. So the final answer is 5 by 20, which is 1 by 4. Now for part 2, the event E is the sentence in the inverted commas, which is getting a blue or black marble. Okay. So what is the number of favorable outcome for this event E? It is actually the number of blue marbles plus number of black marbles, because think about the property of the event E. It says getting a blue or black marble. That means the chosen marble can be any marble among 7 blue marbles, or any marble among 5 black marbles. That's why the number of favorable outcome to E is the number of blue marbles plus number of black marbles. Is it fine? So the answer is 7 plus 5, which is equal to 12 by 20, which is 3 by 5. Now for part 3, they are asking that what is the probability that it will be not black. So for this part, the event E is the sentence in the inverted commas, which is not a black marble, which is actually equal to the event that getting a white or blue marble, because there are only blue, white and black marbles are there in the bag. And if the chosen marble is not black, then it has to be either blue marble or a white marble, isn't it? So the number of favorable outcomes to this event E is just the number of blue marbles plus number of white marbles, which is 8 plus 7. The reason is just the same like the part 2 of this problem. Okay, so the final answer is 15 by 20, which is 3 by 4. Now the last part of this problem is part 4, which says that what is the probability that it will be a green marble. Now we know that there is no green marble in the bag, so the number of green marble is just 0. So for this event E, which is green marble, the number of favorable outcome is just 0, and the final answer is 0 by 20, so it is 0. So here you note that the event green marble is an impossible event because it can never happen, isn't it? So this is question number 9, which says that a bag contains 6 red balls, 8 white balls, 5 green balls and 3 black balls. One ball is drawn at random from the bag. Now what is the experiment here? The experiment is one ball is drawn at random from the bag. That's the experiment. So what is the total number of outcomes for this experiment? It is nothing but the total number of balls there in the bag. Okay, which is 6 plus 8 plus 5 plus 3, which is 22. Because the ball you picked, it can be a red or green or white or black ball. Now for the first part, the question is what is the probability that the ball is white? So the event E for this part 1 is the ball is white. And what is the number of favorable outcomes to this event E? It is just the number of white balls, which is 8. So the final answer is 8 by 22, which is 4 by 11. Now for this second part, the event E is the ball is red or black. It is just the same as the problem number 8 part 2. So I am not going to repeat the reasons. The number of favorable outcomes to this event E will be equal to the number of red balls plus number of black balls. So the answer is 6 plus 3, which is equal to 9 by 22. Now the part 3 of this problem is again same like the problem number 8 part 3. So the event here is not green. That means the chosen ball has to be either red or white or black. That's why the number of favorable outcomes for this event is just the number of red balls plus number of white balls plus number of black balls, which is 6 plus 8 plus 3. So the answer is 17 by 22. Now this part 4 says that what is the probability that the ball is neither white nor black. So here the event E is the sentence in the first inverted commas, which is the ball is neither white nor black. If the ball is neither white nor black, then it has to be either a red or green, because total 4 colors are there in the bag. Okay. Now the event E becomes the ball is red or green. So the number of favorable outcomes is the number of red balls plus number of green balls. So the answer is 11 by 22, which is half.